This next video is going to focus on solving quadratic equations. And to understand what we're about to do is you have to understand the zero product property. It says that if you have two expressions that are multiplied together and they happen to have a product that's equal to 0, then one of those expressions has to be 0. And we're going to have to analyze both of them to get all the possible answers. Now you can do this with as many expressions multiplied together. So you could have an A, a B, a C, even a D, all multiply together and get a 0. You're going to have to figure out then when does A equal 0, B equals 0, C equals 0, D equals 0. It's possible that one of those expressions may not have an answer that can equal 0. That's okay. Best way to figure out what's going on is to see some different examples. And we'll start with example number 1. And I've already done all the factoring, or maybe the problem was provided you with the factors. But the nice thing is you can start right away and look at each piece as the following. You can think of this as A, you can think of this as B, and the fact that if you multiply those together, it says you're going to get 0. So, if I was going to look at the A piece, I am basically saying I need to know when x minus 11 equals a 0. And if I solve by adding 11 to both sides, I will get x equal to positive 11. That's going to be one of my solutions. Now, just to emphasize what I'm trying to get at is I can actually go back, plug it into the original expression. 11 minus 11 times 2 times 11 plus 9. What's important to understand is 2 times 11 plus 9 is not going to be 0. In fact, in this case, it's 31. But the fact that I have 11 minus 11 equal to 0, 0 times 31 happens to equal 0. So, yep, this does work out as one of the answers. I'm going to do the same thing with the second expression, in this case being 2x plus 9. And I need to set that equal to 0. It's going to take a little bit of extra work, subtracting 9 from both sides, coming up with 2x equal to negative 9. And then I'll need to divide both sides by 2. And I can say that the answer is negative 9/2. I can also say it's equal to negative 4.5. And I know this is going to work, but just to show you that it will, if I decide to, let's say, take negative 4.5 and subtract it by 11, because I'm literally putting in, here's my x, and I'm going to put it in x into that spot. And then I was to do the same thing where I go 2 times negative 4.5 plus 9. It's not so much what the second expression, first expression is, which is negative 15.5. It's the fact that the second expression happens to equal 0, and this produces 0. So in this case, I would say that the two answers for this problem is x equals 11 or negative 4.5. And if you want to write negative 9/2, that's fine too. So problem number 2 is where I actually have to do some factoring first. But before you race off and do factoring, you have to understand that the whole point of the zero product property is that the product equals 0. You're not going to get a product equal to 0 if you continue to factor. You're going to get a product that equals 5. And the zero product property does not work. It is up to you to make sure, let's clean that up a little bit. It's up to you to make sure that the equation that you're about to solve for equals 0. So what I'm going to do is I'm going to subtract 5 from both sides. Remember, the constant term will be subtracted from the constant term. So what I'm going to do is get a new problem, x squared plus 10x plus 16 equal to 0. Now, zero product property can be applied. Can be applied. All right, sorry if that's a little sloppy. But now I can do my factoring. So again, I need to figure out that A is 1, B is 10, C is 16. I should have checked that the greatest common factor, which I know right away is 1, so I'm jumping right ahead to the factoring part. I'll need to figure out two numbers that multiply up to 16. I'll need two numbers that need to add up to 10. And those two numbers are 2 and 8. So if I break up the middle term, x squared plus 2x plus 8x plus 16, only difference is I should be adding the equals 0. I can pull out an x out of the first two terms, which is x plus 2. I can pull out a positive 8, leaving an x plus 2. And so I'm going to get two factors, x plus 2, x plus 8, and I'm going to have it equal to 0. And because it now equals 0, I can apply the zero product property. I can essentially say, when does x plus 2 equal 0? And after subtracting 2 from both sides, one of my solutions is x equals negative 2. If I go x plus 8 equal to 0, because that's a possibility, and I subtract 8 from both sides, I will have x equal to negative 8. And in this case, these are my two solutions. So we now move on to the third problem, and it's intentionally meant to be ugly because it's going to involve many components. The good news is, as you can see here, I already have it equal to 0, so that's not going to be one of the issues. The issue is going to be factoring, and what I'm going to do is I'm going to factor all the steps properly, which means first step I should be looking for is my greatest common factor. And there is a greatest common factor, it is 2. So I'm going to need to pull out a 2, and I'm going to be left with 15x squared. Then will come minus 2, oops, close that up, minus 2x, and then minus 24. And again, the whole idea is this is an equation, so it has to equal something, which in this case is 0. I'm going to keep writing down the 0, but I'm really going to put all my focus on figuring out what two numbers. And since A happens to be 15, and C happens to equal negative 24, I know that if I take 15 times negative 24, I come up with negative 360. And it's not writing, so let's try this again, negative 360. If I figure out that my B is negative 2, I'm going to look for two numbers that add up to negative 2. And having done my work ahead of time, I found one number to be negative 20, and I found another number to be positive 18. So as I break up the middle term, 15x squared minus 20x plus 18x, and then minus 24, I can now look at the first two terms here, find the greatest common factor, look at the second grouping of two terms, find its greatest common factor, and do my factoring. All the while, 2 is one of the factors. So I'm going to pull out a 5, and I'm going to pull out an x. This is going to leave me with a 3x minus 4. If I remember that 3x minus 4 has to show up in the second two pieces, I can use that factor, figure out that I need to pull out a greatest common factor of 6 out of those last two terms. And so as I write out all my factors, I know that 3x minus 4 is one factor. I know that 5x plus 6 is a second factor, but I also have a third factor all along, the 2, and those three factors equal 0. So here's what happens. I need to know when 5x plus 6 equals 0. If I subtract 6 from both sides, if I divide by 5, I will come up with negative 6/5. If I go 3x minus 4 equal to 0, I can add 4 to both sides. I'll come up with 3x equal to 4. I'll divide both sides by 3, and I'll come up with x equals 4/3. The reason I brought this problem up is I do have a third factor, and I need to know when 2 equals 0. Well, the last time I checked, $2 is not the same as $0. If it was, I could buy a lot of things, or you could owe me a lot of money for no reason. But the point is, this never happens. And because it never happens. This is never true. You do not have to worry about what x has to equal because this is irrelevant. All right? Since 2 can never equal 0, there's no way to set x equal to something that will make that true statement. So in this case, there may have been 3 factors, but only x equals 4/3 and x equals -6/5 are the solutions to this particular problem. And that concludes solving by factoring.